Hey everyone, and welcome back to Tomorrow's Investing. Today, we're taking a deep dive into the world of semiconductor manufacturing and exploring the cutting-edge technology that's driving the industry forward. Specifically, we're going to take a closer look at ASML, one of the most innovative companies in the space, and see how their technology is shaping the future of the industry. Background on ASML. ASML is a Dutch semiconductor equipment manufacturer that was founded in 1984. The company's name stands for Advanced Semiconductor Materials Lithography, which reflects their focus on developing advanced lithography technology for the semiconductor industry. In the early years, ASML focused on developing stepper machines for photolithography, which is a process used to create patterns on semiconductor wafers. These early machines were used to produce chips with a feature size of around 1 micron, which was the state of the art at the time. In the 1990s, ASML began to focus on developing new lithography technologies that could produce smaller and more complex features on chips. They were one of the first companies to develop a technique called deep ultraviolet (DUV) lithography, which uses light with a shorter wavelength to create smaller features on chips. This technology allowed chip manufacturers to produce chips with feature sizes as small as 130 nanometers. However, even DUV lithography had its limits, and by the early 2000s, chip makers were struggling to produce chips with feature sizes smaller than 90 nanometers. This is where ASML's extreme ultraviolet (EUV) technology comes in. EUV lithography uses light with a wavelength of just 13.5 nanometers to create even smaller features on chips. This technology has been in development for decades, but it wasn't until ASML's introduction of the first EUV machine in 2012 that it became commercially viable. Since then, ASML has continued to improve and refine their EUV technology, and their machines are now used by most of the world's leading chip makers. Their EUV machines are incredibly complex, with over 100,000 individual components, and cost over $120 million each. In addition to their lithography technology, ASML also produces a range of other semiconductor manufacturing equipment, such as inspection and metrology tools. These tools help chip makers to ensure that their chips meet strict quality and performance standards. Overall, ASML has a long history of developing innovative technologies for the semiconductor industry, and their EUV lithography technology is driving the next generation of computing devices. ASML's innovative technology. ASML's commitment to innovation is deeply embedded in its culture and DNA. The company invests heavily in research and development, and its engineers and scientists work tirelessly to push the boundaries of what is possible in the semiconductor industry. The company's most significant innovation to date is its extreme ultraviolet (EUV) lithography technology. This technology is at the heart of ASML's business and is widely regarded as one of the most significant breakthroughs in the semiconductor industry in recent years. EUV lithography uses light with a wavelength of just 13.5 nanometers to create patterns on semiconductor wafers. The technology is incredibly complex, requiring a highly controlled environment to operate correctly and more than 100,000 individual components. Developing EUV lithography was a massive undertaking for ASML, requiring years of research and development and billions of dollars in investment. EUV lithography has the potential to enable chip makers to produce chips with feature sizes as small as 5 nanometers. This is significant because smaller feature sizes mean that more transistors can be packed onto a chip, resulting in more computing power. This, in turn, can lead to more powerful and energy-efficient devices such as smartphones, laptops, and servers. ASML is continuing to invest in research and development to improve its EUV lithography technology. For example, the company is developing new materials for the reflective optics used in EUV lithography machines to improve their performance. They are also working on developing new sources of EUV light that can produce even higher intensities, which would further improve the performance of their machines. In addition to EUV lithography, ASML is also investing in other areas of innovation. The company has made several acquisitions in recent years to strengthen its position in computational lithography, which uses algorithms and simulation to improve the accuracy of lithography patterning. They are also exploring the emerging field of quantum computing and have developed a quantum photolithography machine that uses lasers to control the position of individual atoms, enabling the creation of quantum circuits. Overall, ASML's commitment to innovation and investment in research and development has helped the company to stay at the forefront of the semiconductor industry. Their technologies are driving the next generation of computing devices, and as chip makers continue to push the boundaries of what is possible, ASML is likely to play a critical role in developing the technologies that enable these advances. Benefits of EUV technology. EUV lithography has several key benefits that make it a critical technology for the semiconductor industry. 1. Smaller feature sizes. One of the most significant benefits of EUV lithography is that it enables chip makers to produce chips with smaller feature sizes. This means that more transistors can be packed onto a chip, resulting in more computing power. Smaller feature sizes also allow chip makers to reduce power consumption and heat generation, leading to more energy-efficient devices. 2. Higher resolution. EUV lithography has higher resolution than other lithography techniques, meaning that it can create more precise patterns on semiconductor wafers. This is important because it allows chip makers to produce chips with more complex designs and tighter tolerances, resulting in better performance and reliability. 3. Better cost-effectiveness. Although EUV lithography is a complex and expensive technology, it is actually more cost-effective than other lithography techniques in the long run. This is because it enables chip makers to produce chips with smaller feature sizes and higher performance, resulting in better market competitiveness and higher profit margins. 4. More environmentally friendly. EUV lithography requires fewer processing steps than other lithography techniques, resulting in lower chemical usage and waste generation. This makes it a more environmentally friendly technology, which is becoming increasingly important in today's world. 5. Future-proofing. EUV lithography is a critical technology for the semiconductor industry's future, as it enables chip makers to continue to produce chips with smaller feature sizes and higher performance. This is important because it will allow the industry to continue to push the boundaries of what is possible in computing, enabling new applications and devices that we can only imagine today. Overall, the benefits of EUV lithography are significant and wide-ranging, and it is likely to play a critical role in the semiconductor industry for many years to come. Conclusion. ASML is a leading provider of lithography technology, with a focus on developing innovative solutions for the semiconductor industry. Its EUV technology is a game-changer for the industry, enabling chip makers to produce smaller, more complex chips with higher yields and lower costs. ASML's focus on research and development, expanding into new markets, and strategic mergers and acquisitions have helped it maintain its position as a market leader in lithography technology. The company's commitment to sustainable development is also commendable and aligns well with the growing emphasis on sustainability in the tech industry. The future looks bright for ASML, with increasing demand for advanced chips, continued investment in research and development, expansion into new markets, strategic mergers and acquisitions, and a commitment to sustainable development. However, the company also faces challenges, particularly in scaling up its EUV technology and addressing concerns around geopolitical risks and intellectual property theft. Overall, ASML is a company with a strong track record of innovation and a promising future in the semiconductor industry. Investors and tech enthusiasts alike should keep an eye on ASML as it continues to drive the industry forward with its cutting-edge lithography technology. Thank you for tuning in to Tomorrow's Investing. If you enjoyed this video, please give it a thumbs up and consider subscribing to our channel for more content on innovative companies like ASML.